Hi, welcome to part 3 of vector valued functions. So we have I, j, and k, and there are unit vectors. So that's like right here. And we can write vector equations of multiple variables. So let's take a look right here. Here we have a vector valued function right here. And what we notice right here is that r of x, y. Now normally for vector value, we would use t and u for this. But for this one, we're using x and y. And it's the kind of same idea as if we were to do a function. For example, we could say z is a function of x and y. Y could be written as a function of x and z. And z, or I guess x, could be written as a function of y and x. So this is just a function of x and y. So what they're telling us is x is always 2, y is 3, but z can be anything right there. So what we wind up with here is we have two values here that are constant. They're never going to change. But z, this can be anything. It's never going to change for us. So that can be anything for us right there. And they want us to sketch this graph. Well, it's not that bad to graph. Here's my xy plane down here. My x is always 2. My y is 3. Wherever they meet, there's my point. But remember, z can be anything. So on my z-axis, I'm going to draw up and down. So what we wind up with is a line parallel to the that's terrible, to the z-axis. There we go. We wind up with a line parallel to the z-axis. We can write this in parametric form. Well, in parametric form, we want to eliminate the variable. We want to get rid of one of the variables. So we only have one thing here that is a variable. X is always 2, y is always 3, z is just going to be t. Now, notice up here we said x and y, but when I write my parametric form, I can just write that r of t, because this is not really a surface, it's just a line anyways. So I can write this as 2y plus 3j plus tk. And that would be our parametric equation for our line. So, alright, next one. So take a look here. Well, this is a neat one. They said they want us to write the function in x, y, z form and then describe the graph. So this looks really confusing. But remember, this is a vector function. It's a vector function right there. And this is a vector function of x, z. Well, if I want to write this in a rectangular function, I just look at my independent variables. So my independent variables are x and z. Therefore, what's my dependent variable? Well, if x and z are my dependent variable, my independent variables here, my dependent variable must be y. So I can say y is equal to this 2z plus z squared. I just look for the like component. There's x, there's z, there's y. So y would be 2z plus z squared. And that would be my dependent variable. So that's what you're going to look for. You're going to find that dependent variable. Right there. And this is a parabolic sheet. So let's try another one. R of xy equals x plus y plus this z. Well, there's my x, there's my y, there's my z. So I'm looking for, well, what is my dependent variable? Here. Well, if r is a function of x and y, my dependent variable has to be z. So z is going to become, where is z located? This x squared plus 4y squared. And this is our elliptic paraboloid. Let's graph this real quickly. It's kind of fun to graph. These are the easy ones. X, y. This does open on the z. Opens on z. So it opens up. And there's our elliptic paraboloid. Alright, the last one. Write the equation of xy forms. Describe the graph and sketch the function. So what is this? What's my dependent variable? Well, this is a function of yz. There's x, there's y, there's z. So this is my dependent variable is going to be x. And what's x going to equal? Z squared minus y squared. Oh no, it's our hyperbolic paraboloid. No, not this one. No, don't make me graph it. So let's go and graph that hyperbolic paraboloid. All right, we've done a few of these already. Here's x, y, z. Okay, so xz, that's my main dxz plane. That's my main parabola. And my yx, that's where it's opening. So it's opening down, like this, opening this way. And that's the best I can do. I'm terrible at these. So I do some shading if it looks really bad. So there's our hyperbolic paraboloid. Alright, hope you guys enjoyed these videos, and I'll see you guys later. Bye-bye.